In this video, we're going to analyze what is actually going on with energy in electric circuits. For our circuit, we're going to take a battery that's hooked up to the light bulb. And when we're talking about electricity, we love to make analogies to other situations in which we already understand. So in this video, we're going to look at how a light bulb and a battery in a circuit are like a waterfall. So in this waterfall, water begins at the top of the waterfall and falls to the bottom of the waterfall. We assume that water molecules in the waterfall are like electrons moving in the circuit. So both electrons and water molecules are the circulating objects. So we are able to retrieve some of the energy of the waterfall molecules by adding a water wheel into the middle of the waterfall. The water molecules push down on the water wheel and spin the water wheel. We could then use this spinning crank to spin another apparatus. So it is essentially the tool that we use to extract energy from the waterfall. So in the circuit, we use the light bulb to extract energy from the circuit. So the flowing charges give their energy to the light bulb. The waterfall analogy works well if the top of the waterfall never dries out. However, we need to return the water molecules from the bottom that have fallen up back to the top, and this is done through the water cycle. The water molecules at the bottom of the waterfall evaporate, condense in the sky, and then return to the top of the waterfall through rain. This return to their original state is similar to what the battery does. So in the circuit, the charges have a lot of energy coming out of the battery. They pass through the light bulb and lose the majority of their energy, and they are re-energized by passing through the battery again. Let's look at when both of these situations have the maximum potential energy, when they lose potential energy, and when they gain back their potential energy. So in the waterfall, the water molecules have the most potential energy at the top of the waterfall. And this makes sense because they're the highest above the ground, so they're going to have the most potential energy. And the charges in the circuit are going to have the most potential energy once they come out of the battery. That's when they're feeling the most recharged. So now let's look at when they lose potential energy. So when the water molecules pass over the edge of the cliff and fall into the lower portion of the waterfall, the water molecules are losing potential energy. Alright, and when the charges move through the circuit and move through the wire and the light bulb, they also lose their potential energy. And finally, when we talk about when these molecules gain potential energy, this happens for the water molecules when they are evaporated and return to the top of the waterfall, and the charges in the circuit gain potential energy when they pass through the battery.